got your quiz. Let's talk about that. Yeah, David? Number 4. Which one? You say B? Okay.
A or B.
All right, let's look at those real quick here. We need to find the exact value. That means no calculator. And we're finding the exact value of the tangent of negative 2 pi over 3. All right, so what's the first thing you did, David?
I did the quadrant.
Okay, so you're going to draw a picture.
Yeah.
What angle are you going to draw, though? Well, pi is 180. Divided by 3 is 60, times 2 is 120. So we're drawing a picture in our quadrants of negative 120 degrees. So we're going to come around like this, and it's going to be down here. Because each quadrant is 90, so it would be between 90 and 180, right? Negative 90 and 180. So if this is 120, and this is 180, then this has to be 60 right here. So I got a root 3, a 1, and a 2. Those are the sides of my 30, 60, 90. I am in quadrant 3 though, so these are both going to be negative. And I want the tangent, which is opposite over adjacent. So even if you forgot the negatives, you'd be okay because they cancel out for the tangent. And then the other one says, find the secant of the angle whose sine is 5/8. Now you need to remember that when you see this notation and a positive number, you're going to be in quadrant 1. The sine, I'm starting in the parentheses here, because that's what we do in math class. So sine is 5/8. So I'll do my Pythagorean Theorem like I always do. Every time I have two sides, I find the third. I did it over there. So this side is going to be 64 minus 25, which is root 39. A squared plus B squared equals C squared. And then I want the secant, which is reciprocal of cosine, so that would be 8 over root 39, or 8 root 39 over 39, as the exact value of that. I could type that in my calculator too, but we had no calculator, so. Read?
Number 4.
Yeah, I just did number 4. Okay, I'll do 1 from that then. Yeah, I don't even know where that paper is in the now, so. No, I'll do it. Find the smallest positive coterminal angle for pi over 11. All right, he needs to find the smallest positive coterminal angle for pi over 11. How do we find coterminal angles? Add or subtract a revolution. Since that angle is in radians, a revolution would be 2 pi. So I just get a common denominator, so 1 pi over 11 plus 22 pi over 11 gives me 23 pi over 11 as my answer. Coterminal angles, you add and subtract a revolution. That's it. In degrees, 360, and radians, 2 pi. All right, one more quiz question. Here we go, Grace.
Number 3.
3, what is the period of this? Well, what is the period of the first part? 2 pi over 3. And what is the period of the second part? There's where we run into problems. Be careful, that's a tangent. What is the normal period of a tangent? Remember what a tangent looks like. What is the normal period from negative pi over 2 to pi over 2? What is that normal period? Pi. So this is going to be pi over 1/2, which is 2 pi. Is that your mistake? Did you say 4? Yeah. So they overlap. This one's 0, 2 pi, 4 pi over 3, 6 pi over 3, which is 2 pi. So the period is 2 pi. Remember, sine and cosine have a standard period of 2 pi, but the tangent is different. Tangent and cotangent are pi. Okay, one more. Is that it? Done? All right, let's pick up with our review then. We were in the, on the pretest. Okay, so we're on the pretest. And I think we had stopped with number 8. Seems like forever since you were here. But I marked number 8, so I think that's where we ended. So number 9. In which quadrant is an angle if its cosine is negative and its sine is also negative? So cosine is negative and sine is negative. Remember, less than 0 means negative, right? Less than 0, negative. So, easy peasy if you remember that cosine is which letter? X. And sine is y. So this basically says x is negative and y is negative. Where does that happen? Quadrant 3. That's right. So this is in quadrant 3. The sine and the cosine are both negative in 3 because x and y are both negative.
Which one are we on?
We're on the pretest. It's called Pretest Chapter 4. All right, number 10. Find the exact value. So this was on your quiz. Well, no, not really. Not really. This is just easier than the one on your quiz. Remember, when you see this notation, if this number's positive, you're going to draw your picture in quadrant 1. If it's not positive, you have to remember the rules. What is the rule for an inverse sine negative? What quadrant? 4. That's right, quadrant 4. So you're going to draw your picture in quadrant 4. Those are just the rules, kids. You just got to know the rules. That's quadrant 4. So the sine, that's root 3 over 2. That makes that a 1. And you need to recognize that angle. If that's a root 3, then this has got to be a 60. But you can't say 60 because 60 would be in quadrant 1. This instead you're going to say negative 60. It's negative 60 degrees. That puts it in quadrant 4 where it needs to be. Now 11 is like the one that was on your quiz. Cosine, inverse tangent, 3/4. So we're going to find the cosine of the angle whose tangent is 3/4. So see that notation, and positive. So we're going to draw it in quadrant 1, because that's where we draw things when they're inverse functions and positive numbers. So opposite over adjacent is 3/4. We'll do our Pythagorean Theorem, or maybe you know that one because we use it a lot. It's called a Pythagorean Triple. This is 5, right? A squared plus b squared. And I have no idea how big that angle is. Like, I knew this was 60, but I don't really need that angle. I need to know its cosine. So the cosine is 4/5. In number 12, we just talked about. This one, though, is a sine and a cosine. So what's the period of the first piece? 2 pi over 1/2, which is 4 pi. And the second piece is 2 pi over 2/3, which is 2 pi times 3/2, which is 3 pi. So we got a 3 pi and a 4 pi. So think about where they overlap. Write it out if you need to. You've got 3 pi, 6 pi, 9 pi, 12 pi, 15 pi, and on and on and on. And that's the 3. Then we've got 4 pi, 8 pi, 12 pi. There it is, right? So the period is 12 pi. You don't have to write it out, but if you can't figure it out, that's a good way of deciding. Okay, so remember your test will be split up, calculator, no calculator. So all the problems we've done today so far, we haven't needed a calculator for. Now we need one. For these word problems, we need a calculator. So, when you read your little word problem, what is the first thing you're probably going to do? Draw a triangle, right? You're going to draw a picture of the situation, and for us, in this chapter, they're all triangles. So here we go. We got Charles in the top of the tree. He's up here. The tree is 32 feet tall. His angle of depression is 23 degrees. How far, here's the book. How far is Charles from the book? So where do I put the X? On the hypotenuse. There's Charles, there's the book, that's X. So now you've drawn the picture. So what's the next thing you do? You write an equation, and the equation is always going to be a sine, cosine, or tangent, right? So if you look at your picture, and Ellie says it's a sine, would you agree? And it's always sine angle, so it's going to be sine 23, and then opposite over hypotenuse. So we'll multiply by x and divide by 23. Now we've done so many of these that some of you can skip that middle step and go straight to this. If you want to, just make sure you're dividing in the right order. So 32 divided by sine 23. Oh shoot, make sure you're in degrees. Did you get 81.9? And don't forget, put a unit on that, remember? All your word problems, make sure you label your answer. So 81.9 feet. All right, that was pretty easy. All right, okay, now pay attention to the next one. Now we're going to need a compass, because we've got this guy on a course going speed and all that stuff. So we draw our compass, right? And if we need the labels, remember how they're labeled on a compass. This is not the way normal trigonometry works, but that's how you label the compass. All right, so the ship sails from port on a course due west. So the guy is going due west. So we'll call this port. Erase this stuff. Here he goes, due west. Okay, there he is. Now, he is going at a speed of 4 miles an hour. Remember, a knot is a nautical mile per hour. So he's going 4 miles an hour for 6 hours, right? So you're going to mark this 24 miles, right? He is going 4 miles an hour for 6 hours. Then he turns due south. Okay, so here he is. Now he's going to go due south, so straight down. But he's only going 2 hours at a speed of 10 knots. Or no, 2 hours, 5 knots for a distance of 10. I was getting ahead of myself there. So this is 10 miles. 2 hours at 5 miles an hour. So now he's here. And now we want to know what his distance and direction from port are. So we want to know the length of the green segment, I'll call it X. And then we also want to know this angle right here, because that would be his direction. Remember, measured from due north. So we want to know the angle of the green vector. All right, well first let's find the length. The length is easy. If that's due west and that's due south, isn't that 90? So we can just do the Pythagorean Theorem. Now, I think I told you this already, I'll tell you for sure. In the next chapter, that won't be a right angle, so we'll have to have some other skills. But right now, they're right angles, so we can always use the Pythagorean Theorem. I think that works out nicely, too. I think that's another Pythagorean Triple. Yep. So how far is he from port? He's 26 miles. 26 miles from port. Now, finding that green angle would be difficult, but it's easy to find this one. Look where my finger is. Can I find that angle pretty easily? Yep. I'm going to call that angle theta. And I know that the tangent of theta is 10 over 24. Now, in this case, I could have used sine or cosine because that's not rounded off. But normally, that would be like 26.832 or something. So I wouldn't want to use it. I want to use the numbers that I started with. So that's why I picked tangent. So I'll go to my calculator. How do I type that in? How do I find theta? Second tangent, right? So inverse tangent, 10 divided by 24. And that gives me 22.62 degrees. Now, that is not his course, right? His course is the green angle. So how am I going to find the green angle? Look, use your head. Be logical about it. How am I going to find the green angle? From? 270. Exactly. Isn't all the way around to the purple 270? But I want to stop here. So I'll just subtract from 270. And his course is 247.38 degrees.
Can we go over a problem that where it lands on like the 90 degree or the 180 degree or 270 degree?
Okay. I don't know what you're talking about. Why don't you find one? I'm going to keep rolling through the sheet. You find what you're talking about. Okay, so Robbie is walking at a pace of 2.5 miles an hour toward the Algebra Scholars building. All right. So here's the building. At one point, his angle of elevation to the top of the building is 54. Okay? After 30 minutes of walking, so he's walking toward the building, so he's walked for 30 minutes, now his angle of elevation is 62 degrees. How tall is the building? Now, there's a piece of information I know that I haven't put in my picture yet. Did you pick up on it? What do I know that I haven't labeled yet? What? 2.5. Okay, now be careful. The 2.5 is, he's walking 2.5 miles an hour, right? So that means if he walked for a whole hour, he'd go 2.5 miles. How long is he walking? Which is half an hour. So he's not going to go 2.5 miles. How far is he going to go?
1.25.
1 1/4, 1.25. So this distance right here is 1.25 miles. He's walking 2.5 miles an hour for half an hour. Okay. I need X. Can't find it outright. So we're going to have to build a couple of equations. So let's look at this little right triangle right here. You have two right triangles. You have this one and you got the whole one. Okay? Please don't try to do SOHCAHTOA in this triangle because it isn't right. Okay? This requires the law signs or cosines. We're going to learn that in the next chapter. But right now, we're got to do right triangles. So in this right triangle, I'm going to go ahead and call this y. That's this piece right here. We're going to call it y. The tangent of 62 equals x over y. Would you agree with that? Now, what about the big triangle, the whole big one? Can I write a similar equation for it? Yep. Tan 54 equals what?
X over 1.25.
Yep, that's exactly right. X over opposite over adjacent. So x over 1.25 plus y. Now, this looks different, but it's exactly what you know how to do from Algebra 1. Your teacher gave you about 18,000 problems like this to solve, where you had two separate equations and they had two different variables in them, right? And what did you do when you had that? You substituted or eliminated. That's right. So we've got this system of equations, both have x's and y's. Elimination is going to be kind of hard. So what I like to do, and I think it's easiest in ones like this, is I'll get x by itself. So x equals y tan 62. And x equals, I'm going to multiply this over to here. So I have x by itself. So x equals 1.25 tan 54 plus y tan 54. Why did I do that? Because now I can set them equal to each other. And then instead of having two variables, I'll only have one. So y tan 62 equals 1.25 tan 54 plus y tan 54. Just set these two things equal to each other since they're both equal to x. Now to solve that, I'm going to have to put the y's on the same side of the equation. So I'm going to bring this term over to here. So y tan 62 minus y tan 54 equals 1.25 tan 54. Now, I'll factor out the y. So I have y times tan 62 minus tan 54 equal to 1.25 tan 54. How am I going to get y? What am I going to have to do to get y all by itself? Divide. So y is going to equal 1.25 tan 54 divided by tan 62 minus tan 54. So now I'm ready to go to my calculator. If you have your calculator, please type this in with me because this can be a little bit tricky to type in. Remember that whenever you have two things in your denominator, you've got to put parentheses. No matter whether they're being added, subtracted, multiplied, doesn't matter. You need parentheses if you have more than one thing in your denominator. Now, what I want to caution you about is when you do 1.25 tan 54, you see how it automatically puts these parentheses in? You need to close them. Because if you don't, it's going to take the tangent of everything you type in, which isn't what you want. You want only the tangent of 54. So close those parentheses, hit divided by, put some parentheses in now, and it's tan 62, close them around the 62, minus tan 54, close a couple of parentheses there, and I got 3.41. Is that what you got? You get 3.41?
Yeah.
Okay, so we just did all that work and we're so excited, but that isn't the answer to the question. That's why. And the answer to the question is X, right? How tall is the building? But it's easy. Look up here. X, from your original equation, X is y tan 62. So all we need to do is take the number on the calculator and times it by tan 62. I got 6.42. Did you? Now, this is a crazy problem. Obviously, I made it up. The unit on that's miles. So that building is 6 miles tall. That's kind of goofy, but that's how it came out. Okay.